Hey classmates, this is Unson here, and for my discussion number 10, I will be doing problem number 15 from chapter 13:9. The problem is maximize revenue. A company manufactures two types of sneakers, running shoes and basketball shoes. The total revenue from X1 units of running shoes and X2 units of basketball shoes is R is equal to negative 5x1 squared minus 8x2 squared minus 2x1 x2 plus 42x1 plus 102 x2, where x1 and x2 are in thousands of units. It wants us to find the number of shoes, basketball, and running that will maximize its revenue. For this problem, instead of using x1 and x2, I just used x for the running shoes and y for the basketball shoes. So the original equation they gave us here was r is equal to negative 5x squared minus 8y squared minus 2xy plus 42x plus 102y. And so first step that you take in any optimization problem, because that's what we're doing, we're trying to maximize the revenue, is to take the partial derivatives in terms of x and in terms of y. So if we go here, our first one, the partial derivative with respect to x is equal to negative 10x. You can skip the y because it's just a constant. The next one will be negative 2y plus 42. And that last term right there is also a constant, so we don't have to worry about that. Now the partial in terms of y is r sub y is equal to negative 16y. In the middle here we've got negative 2x, and at the end we have plus 102. So what we're going to do here is we're going to set the first equal to 0, and we're going to set the second equal to 0. So now that we've got these two, we've got a system of equations here. And to solve this, since they're both equal to 0, I'm going to go about doing the elimination method. So what we're going to do is we're going to multiply both sides of this one by a negative 5. So if we bring down our first equation, the r of x and now to cancel it, we will put negative 5 times 2x is a positive 10x, and then we will take the y, which is a positive 80y minus a 510. And so when we combine those, we get 78y minus 468 is equal to 0, which gives us 78y is equal to 468, which then allows us to solve for a y equal to 6. Just got to shrink everything there. And so now that we know that y is equal to 6, we can go back into our r of x equation, or r of y. I just chose the r of x equation, and plug in that y to solve for x. So we have negative 10x minus 2 times 6, which is our y that we solved, plus 42 is equal to 0. And so when we solve this, we get, I'm going to move the 10x to the other side, and we get negative 12 plus 42 is equal to 10x. This means that 30 is equal to 10x, which gives us x is equal to 3. So that gives us right there our critical point of 3, 6. And now that we have our critical point, we'll need to figure out if it's a maximum or a minimum. To do that, we'll need to find the discriminant of r, and to do that we need the second partials of x, y, and xy. So if we look back up here to our r of x, and we take r of x is equal to negative 10. The negative 2y is a constant, so it just goes away, and the 42 is a constant, so it goes away. Then we have our r of yy, which is equal to negative 16. The negative 2x and the 102 are also constants, so they'll just go away. And when we do r of xy, we get the negative 10x goes away, the negative 2 comes down, and the 42 is also a constant, so it just goes away. So now we've got these three values here. So we know that our discriminant of our point, critical point right here, 3, 6, is equal to r sub x at 3, 6 times r sub y at 3, 6 minus r sub x y of 3, 6, whole quantity squared there. Now, the nice thing, or maybe the easy thing about this problem, is that our second partials are the same at every single value. So it really didn't matter that we were at the specific critical point. The second partial will always be the same for this problem. It may not be the same for other problems. So then when we solve for our discriminant here, we have our discriminant at 3, 6 is equal to our r sub xx is equal to negative 10. We multiply that times our r sub yy, which is negative 16. And we are going to subtract our r sub xy squared from it. Looking at it already, we can tell that it's going to be positive. But to be exact, it is 160 minus 4, which is equal to 156. Now, since it's equal to 156, and that's greater than 0, we can continue on. And we know that since r sub x or r sub y, it doesn't particularly matter which one you choose, but that at 3, 6 is equal to negative 10. And since negative 10 is less than 0, it means that it is concave down. So now that we know that it's a concave down, that means it has a relative this means that it has a This means that it has a relative max at some value at the point 3, 6, because that's our critical point. This means it has a relative max of some value at the point 3, 6. So to go about finding this value, go back up to our original equation. So we have that R is equal to -5, our X is 3 in this case, squared, minus 8, our Y in this case is 6 squared, minus 2 times 3 times 6, plus 42 times 3, plus 102 times 6. When we go about solving this, we get -45 minus 288 minus 36 plus 126 plus 612. This gives us a total value of 369. And now, if you remember back from the beginning of the equation, all these values are in thousands. So this means that the max revenue will be $369,000 when the company sells 3,000 of the running shoes and when they sell 6,000 of the basketball shoes.